Hello everyone. In today's video, we'll be discussing about JVM's architecture in a high level, and in this upcoming videos, we will discuss what is each of this component in detail. And maybe for this video, there might be new terms coming up, but please bear with me. And once you see a lot of videos going forward, all these things, if you revisit back, all these things will be more clear. Okay, so let's start. So in the JVM, right, you have three main components. One is your class loader, and one is your runtime data runtime area, which is your memory, your memory area, and then you have your execution engine. So these are the three main components, and then you have your native method interface, native method libraries and stuff. I'll discuss what they are. So now class loader. What is a class loader? So class loader will only load your class files. We will discuss what a class is, but for now, imagine like in every Java program, you have your main method, right? So the main method will be inside some class. So that class is your main class, right? So firstly, the class loader will load that particular class, okay? And then that is the only responsibility of your class loader, and there can be many other function calls that can happen from your main method, right? So the program always starts from your main method, which is inside some class. So the class loader will try to first load that particular class into the JVM will load that particular class, and then in the main method, if say you have some other method call, and that method is present in some other class, then on demand, whenever needed, on demand as in whenever needed, when you make another function call and that function is present in some other class, then that particular class will be loaded by the class loader. So until your program is finished and until it executes and terminates fully, whatever the classes are needed and dependent for your program to fully execute, those all classes will be loaded by your class loader on demand. So that is what is your job of class loader. And then comes your data runtime area. So everything here that you see will happen at the runtime once you run your Java code, and JVM will be doing all these things. So in JVM memory, which is your data runtime area, so this entire block, there are five components that you see here, right? All these five components are just different parts of your RAM. Like they are just, they represent the same memory, but they have like different parts in it, and specific, each of this is used for a specific use. Okay, and now what is method area? So now method area is where you have your entire code or entire program. You can imagine, or you can think about this as that every programming language, the main method is where the program execution starts. Similarly in Java, you have a class in which you have your main method, right? So that particular main method is the start part of your program, and the entire main method code and everything is uh, present inside your method area. And whenever the JVM will start executing the code line by line from this JVM method area. So it will go to this method area, it will go line by line, what is the first line to execute, second line, third line, fourth line, subsequently, so on and so forth. It will take each of the line from this part and start executing the code. What is your second component, which is heap area? Heap area is something which is like empty. Before your program starts, it's basically empty, and on demand, like dynamically, whenever during the runtime you need anything, the memory is allocated in the heap area. Particularly if I have to tell it in Java's context, all your objects are created inside your heap. Let's say in your main method you are trying to create an object of some particular class, then the memory is allocated to that particular object, and that memory or that object will reside in your heap, and you will just have the reference of that particular object. So all your object creations and everything will happen runtime dynamically during the program execution inside your heap area. So this is where you will have all your objects getting created. Okay, and then you, what is this stack here? Okay, so stack is very important here. So this is a method stack. So as you know, we will discuss it later, but stack is a data structure which follows first last in, first out. approach. So whatever goes last, that comes out first. Okay, that's what stack uses. So it means here the method stack is used to keep a track of the function calls. Let's say, take an example that inside your main method you have function 1 and you have function 2. So whenever you see a function call, the JVM will push a record inside this stack that you have to visit F1, and once you go to F1 and execute all the statements inside F1, you come back again to the same point, right? When you come back again to the same point, you pop the record from the stack that F1 function execution is fully completed, and then you go ahead with the regular program flow. And when you find another function F2, you will push that function uh, record on the stack, and you will go and execute what is inside F2. Once you complete all the lines that are there inside a function F2, you will come back again to where you started. Similarly, so on and so forth. So whenever you find any function call, or whenever you want to keep track of the method calls, this stack is used, and a record is created here so that to keep a track of the program execution flow. And now the record that you create inside the stack to keep a track of which function you have called and where the program flow is going, that particular record on this stack is called execution context. Like in different languages and all, people generally use different terms. In some places they use the word execution context, some people call it as activation record, some people call it as stack frame or execution frame. Whatever it is, the activation record or the execution context created inside the stack is just a method function call that we are keeping a track of when to visit that function and execute and come back to which particular line in your main method. So that is what this stack is used for. And the fourth component is PC registers. So what is PC registers is basically the PC word stands for program counter, and basically this holds some address, PC register. So what it holds is what is the next instruction that has to be executed by the JVM. That address will be maintained here in this PC register. So it's simple. So whatever the next instruction that in the program flow that the JVM has to execute, that thing will be maintained here inside your um, PC register. And what is this thing? The last thing is your native method stack. Similar to what the method stack is, this is also something similar, but the difference comes here that native method stack, when the word native comes in, your Java JVM is responsible to do all these things that we are discussing so far, right? Which is particularly related to your Java program or your Java code. But what if the JVM has to interact with your operating system and it has to tell something to the operating system, and the operating system will do something? Like when you open a file inside your file system, generally what is happening behind the scenes? The operating system, when you double click the file, the operating system call is being made, and the operating system is allowing you to interact with the hardware and open your file and allowing you to write something onto the secondary hard disk. So the OS layer is in between your hardware, acting as a software layer, letting you interact with the system. So similarly, so the system calls, whatever system calls you have, that needs to interact with the OS. All such system calls JVM will not do directly, but instead of that, your JVM will have those system calls separate out from the normal program execution, and those system calls and all will be maintained here in the methods, native method stack. So if there are multiple system calls, then each of the system call will be created as a record inside the stack to keep a track record of which system call happened and what is next. So whenever one system call is finished, you will just pop it from the stack and then you will again push it the next particular thing. So similarly, that's what happens here. Now the thing is execution engine. What is execution engine? So execution engine is the core heart of your JVM, where the actual execution happens, like your Java compiler and your basically JIT compiler. Everything comes under this execution engine because this is where the execution happens. This is where the above part, these five places are where you have your code or your memory and addresses and things keeping track. Everything is there here, particularly the memory part. The execution will happen here. And the last thing is the native method interface and native method libraries. So these are nothing but if you have some code which is not written in Java, like all this part is understood by JVM, and this is something that the JVM will understand and everything specific to Java, but you have some native system calls or system related stuff. Whenever the word you see native, it is more towards your operating system or the system hardware related stuff. If you have something separate, so you will maintain all these libraries and methods here, and there is something called as a native method interface as part of this JVM architecture. So that is responsible to interact with your system related libraries and methods, which are native methods and libraries, and that will interact with your native method interface, and that will eventually be called or involved in your execution engine, whatever is there as part of your program. I hope this is clear. So that's it for this video.